Assalamu alaikum. Welcome to the Fareaa Yousuf Math Lounge. And the topic that we are going to do today is quadratic equations by completing the square method. So in the previous class, we just solved the equations, the quadratic equations by the method of factorization. Today, we will be solving it by another method, which is called completing the square method. So we will be solving examples to see how the expression or the equation can be solved by completing the square method, and then also we will understand the significance of completing the square method graphically. So let's start. So the first question that we have here says, write the expression in the form ax plus b the whole square plus c. So we can see here that x plus b the whole square means it involves the algebraic identity a plus b the whole square or a minus b the whole square, which is equals to a square plus 2ab plus b square or a square minus 2ab plus b square. So let's start working on it. So the expression that is given to us is 6x squared plus 12x and minus 3. So whenever we have this expression and we have to solve it by completing the square method, just remember that the coefficient of x squared needs to be a 1 while solving by completing the square method. If it is not a perfect square, like I can see here that 6 is not a perfect square, so I should be taking 6 common from the entire expression and solving it by the method. So if I take 6 common, I will be left here with x squared plus 2x and a minus 3 by 6, or I can say it's 6 common, x squared plus 2x and a minus 1 by 2. 3 by 6 can be written as a 1 by 2, simplified as a 1 by 2. Now to start with the process, I have written some steps here. The first step is to divide the coefficient of x by 2. So dividing the coefficient of x by 2, I can see that in this expression that I have, the coefficient of x is a 2. So if I divide 2 by 2, my answer is a 1. Second step is add and subtract the squared result to the expression. I should be adding and subtracting as well 1 the whole square. So to do that, I can say it's a 6 common. I will be having here x squared plus 2x. First, I will be adding the squared term, and then to balance the equation, I will be subtracting the squared term as well. So I can see that the first 3 terms now are representing a squared plus 2ab plus 1 the whole square. Now a squared plus 2ab plus 1 the whole square can be written as a squared plus 2ab plus b square can be written as a plus b the whole square. That means I can say that my term is left with x plus 1 the whole square. I can just rewrite it as the algebraic identity, which is x plus 1 the whole square, and solving it further, I can say that this is six x plus 1 the whole square and a minus 1 by 2 minus 1, that will give me a minus 3 by 2 here, and then I can just multiply the bracket by 6 and 6 times 3 by 2, and I can simplify it further and I can say it's 6 times x plus 1 the whole square and a minus 9. So this is what the question asked us to do. The question asked us to write the expression in the form of a times x plus b the whole square plus c. So this is our completed squared form, and I can just compare it and say that my a value is a 6 and b value is a 1, and we have this constant c, which is a negative 9. So this is the expression that I have at the moment. Now the significance of the completed squared method, to discuss that, let's move on to the previous concept, which said that the coefficient of x squared, whenever positive, we shall be having the minimum turning point curve. Always the curve that we shall be having here is going to be a minimum turning point curve. That is because the coefficient of x square was a positive. That was because the coefficient of x square was a positive. So this is the curve that I should be having at the moment. And also, it's because a is greater than 0. 6 is greater than 0 in this case. And also I know that my y-intercept is a -3. So I know the basic structure of the curve here. Now, with the help of completing square method, I can get the turning point of this quadratic curve. How? Let's see how we shall be getting that. I got the completed squared form, which was 6 bracket x plus 1 the whole square and a -9. To get the completed squared form, after getting the completed squared form, we can have the turning point by just saying that this is x plus 1, which is equals to 0, and x will be equal to -1. This value of x, which is a -1 from the squared bracket, is actually the turning point x coordinate here, which is a -1, and the constant here is actually the y coordinate of the turning point. The constant is actually the y coordinate of the turning point. So I can very well say that the turning point has coordinates which is -1 and a 9, meaning this point here is a -1 and a 9. So to sketch the curve properly, turning point is a -1 and a 9. So I'm just making an exaggerated curve. Turning point is a -1 and a 9. So, turning point is a -1 and a -9. And also I know that my y-intercept was a -3. It's a curve of minimum nature. So I can say that this is how my curve shall be, with the turning point as -1 and -9. So this is the significance of completing the square method, that I can get the turning point after expressing it in the completed squared form, and then I can sketch the curve just by looking at the sign of the coefficient of x square and the y-intercept. Let's do another example. 5x square minus 20x plus 2. Again, I need to express it in the form a bracket x plus b the whole square and a plus c. And also I would say sketch the curve. I would say sketch the curve. Sketch the quadratic curve for the given expression. So again, I need to have the coefficient of x square as 1. For that purpose, I will be taking 5 as common. I will be left here with x square minus 4x and then plus 2 by 5. So following the steps, let's follow the steps. Number 1, divide the coefficient of x by 2, and in this case I know that the coefficient of x is a 4, so I will be dividing 4 by 2. That will give me a 2 again, and add and subtract. The second step is to add and subtract the squared result to the expression, meaning I should be adding plus and minus 2 the whole square to the expression here. So to start working on that, I can say it's a plus 2 the whole square, and then I have a minus 2 the whole square as well. And I can see that the first three terms that we have, they are representing a square, minus 2ab, and a plus b square. So with that, I should say that my algebraic identity here is x minus 2 the whole square plus 2 by 5 minus 4. Solving it further, I can say it is x minus 2 the whole square minus 18 by 5, or I can just bring this 5, multiply it by the squared bracket, and then multiply it by the constant also, and I can have my completed squared form as 5 times x minus 2 the whole square and a minus 18. So this is the completed squared form which was required in the question, and I have my answer here. After that, I can get the turning point, and for the turning point, we know that we have to equate the squared bracket to 0. Just remember, when we are getting the turning point of the x coordinate of the turning point, simply change the sign of the bracket so that I can say that if h is the x coordinate of the turning point, then the coordinate of x or h here is equals to 2, and the constant in the equation will be representing the y coordinate of the turning point. So I have the turning point coordinates as 2 and a negative 18. This is the curve which had the coefficient of x square greater than 0. I had 5 as the coefficient of x square. So 5 is greater than 0. Therefore, it has to be a minimum turning point curve, and also the y-intercept here is a 2. I have the main information. I have in fact all the informations to construct or to plot the quadratic curve here. I know very easily I can sketch the quadratic curve. I have the y-intercept, which is a 2, so I'm making the y-intercept on the positive y-axis. I know that the nature is a minimum nature. I have already sketched the minimum natured quadratic curve, and also I know that it's passing the turning point. For the turning point x coordinate is a 2, so it's 2 here, and my turning point coordinates are going to be 2 and a negative 18. So this is how easy it becomes to sketch the quadratic curve after solving it by completing the square method. Let's solve another example. Third example that we have says it's a negative 2x square, negative 2x, and a plus 5. So again, express it in the form a bracket x plus b the whole square and a plus c, and also sketch the curve. This is what the question says. So again, I have to take negative 2 common. I will be left with x square plus x and a minus 5 by 2. Start following the steps for completing the square method. Divide the coefficient of x by 2. Now in this case, I can see that the coefficient of x is a 1, so I should be dividing 1 by 2. Add and subtract the squared result to the expression, meaning I should be adding 1 by 2 the whole square and also subtracting 1 by 2 the whole square. So doing that, I'm adding and subtracting because I need to balance the equation. I should always, when I'm doing something on my own, I should always be balancing it. So adding it, that means I need to subtract it also. If I multiply an equation by a number, then I need to divide also to have a balance over there. So it's a negative 2 here, and then this is x square plus x, add 1 by 2 the whole square, minus 5 by 2, and then subtract 1 by 2 the whole square as well. Or I can say it's a negative 2 and x plus 1 by 2 the whole square, minus 5 by 2 and a minus 1 by 4 here. Solving it, it's negative 2 x plus 1 by 2 the whole square and a minus 11 by 4. Solving it further, I can say it's minus 2 multiplied by the square bracket and minus 2 also multiplied by negative 11 by 4. So now I'm getting the completed squared form, which is negative 2 bracket x plus 1 by 2 the whole square and a plus 11 by 2 here. So this is my completed the squared form for the expression that we have. From here, I can also get the turning point, and the turning point here is going to be x plus 1 by 2 equated to 0, that will give me the negative 1 by 2 x coordinate of the turning point, and also it should be an 11 by 2 the y coordinate here. Now to sketch the curve, after expressing it as the completed squared form, I got the answer, and my answer here was negative 2x plus 1 by 2 the whole square and a plus 1 11 by 2. This is the completed squared form, which should be a bracket x plus b the whole square and a plus c. So what I see here is that the a value is a negative 2. So if this is a negative 2, I know that the nature of the curve has to be a maximum. My a in the expression which I initially had, the expression that I initially had was minus 2x square minus 2x plus 5. I can see here that a is less than 0, therefore the curve has to be of maximum nature. The second thing that I know is the y-intercept, which is a 5, and then I have the turning point coordinates with respect to the completed squared form, negative 2x plus 1 by 2 the whole square plus 11 by 2, and my turning point coordinates were negative 1 by 2 and then 11 by 2. So if I need to sketch the curve with respect to the information that we have gathered, we can see that the curve has to be of maximum nature. So I can very well sketch the maximum turning point curve having the turning points as negative 1 by 2 and 11 by 2, which is a 5.5, 11 by 2 positive y-axis, and also I have the y-intercept, which is a 5 here. So this is how very easily I can sketch my quadratic curve with a maximum turning point. So this was my turning point coordinate here. So this is again how easy it becomes to sketch the curve with respect to the completed squared form of the quadratic expression.